Hello my dear lovely students, welcome back to my channel. In this video we are going to discuss the third chapter of class 6, which is number play. The videos for the previous chapters have been already uploaded. Let's start with numbers. Numbers are used in different contexts and in many different ways to organize our lives. We have used numbers to count and have applied the basic operations of addition, subtraction, multiplication and division on them to solve problems related to our daily lives. Numbers are used differently in various contexts. Sometimes we use numbers for ranking, sometimes for scoring, and sometimes just for naming. Like the number on a cricket player's jersey, these numbers don't indicate rank or score but serve as identification. Think about various situations where we use numbers. List 5 different situations in which numbers are used. See what your classmates have listed, share, and discuss. 5 different situations where numbers are used. First one is shopping. Numbers are used to calculate prices, totals and change when buying items. Next, cooking and recipes. Numbers help measure ingredients and follow cooking times for recipes. Next, counting. Counting the numbers. Next, time management. Numbers are used to tell time, set alarms and manage schedules. Next one, sports and games. Numbers are crucial for scoring, keeping track of points and measuring performance in sports and games. Next, budgeting and finance also will come. Numbers are essential for managing money, calculating expenses, income and savings. The next one is 3.1. Numbers can tell us things. What are these numbers telling us? Some children are standing in a line and saying a number. Can you see? Each student is saying number and the number is written above them. What does this number mean? Now observe carefully and think about what it could be. If you get the answer, that's great. Otherwise, we'll see further. What do you think of these numbers mean? The children now rearrange themselves and again each one says a number based on their arrangement. Now the children rearrange themselves and say a number based on their new position. Let's see. Could there be heights playing around? Is something related to heights being discussed here? The first child is saying 1. Next child is saying 0. Because if you observe here, the child 0 is taller than child 1 and 2. Next, 2 is shorter than the child 0 and child 1. Next, 1 is taller than the child 2. A child says 1 if there is only one taller child standing next to other. If child says 1 if there is only one taller child standing next to them. This means that if a child is standing here and there is only one child taller than them on either side, they will say 1. A child says 2 if both the children standing next to them are taller. So, a child says 2 if both the children standing next to them are taller. This means that if both the children on the left and right sides are taller, the child will say 2. A child says 0 if neither of the children standing next to them is taller. This means that if there are no taller children on either side, so the child will say 0. Now looking at the figure above, you can understand why a particular child is saying 1, 2 or 0. Each person says the number based on the heights of the children standing next to them. So the first child said 1 because only one taller child standing next to them. Next, a child says 2. Both children standing next to them are taller. So the child says 0. Neither of the children standing next to them is taller. This child says 2 because both the children standing next to them are taller. This child said 1 because only one taller child standing next to that one child. Like this, they mentioned their numbers. Now we are going to solve some questions based on this figure. Try answering the questions below and share your reasoning. The first question is, can Children rearrange themselves in such a way that the children standing at the ends say 2. So, in the question, what they asked, the children rearrange themselves so that the children standing at the end say 2. It is not possible because a child can say 2 only when both their neighbors are taller. Since a child standing at the end has only one neighbor, they can say 1 at most, but not 2. So, the answer is no, the children standing at the ends can never say 2 because they have only one child next to them. Moving to the second question. The second question is, can we arrange the children in a line so that all would say only zeros? So, what is the question here? Can we arrange the children in a line so that all would say only zeros? Yes, it is possible, but when? Only if height of all the children is same. Moving to the third question, can two children standing next to each other say the same number? Yes, it is possible. One possible arrangement is when two children have the same height and the children on the either side of them are taller. For example, if we have children A, B, C and D, B and C have the same height while A and D are taller than B and C, then B and C can both say 1. So, one possible arrangement is, suppose child B and C are the same height while the child A and D are taller than the B and C. Moving to the fourth question. There are 5 children in a group, all of different heights. Can they stand such that 4 of them say 1 and the last one says 0? Why or why not? Let us consider this first. If we arrange the children in ascending order of their height, it works out. The shortest child will say 1 because there is one taller child on the right. The next child will also say 1 because there is one taller child on the right. This continues until the last child, who will say 0 because there are no taller children on either side. This scenario will work. So the answer is yes, only it's possible if they are arranged in ascending of their heights. This is possible for arranging in ascending order. Moving to the fifth question. The fifth question is, for this group of 5 children is the sequence 1, 1, 1, 1, 1, 1 possible? The answer is no, it is not possible because if 4 children say 1, the last child will say 0, not 1. So the answer is no. The sixth question is the sequence 0, 1, 2, 1, 0 possible? Why or why not? Yes, this is possible. Only one way to arrange the children is to have the tallest child is first, followed by the second tallest, and so on. The arrangement would be tallest, next second tallest, next third tallest, which is the shortest arrangement, next fourth tallest, and the second shortest. So the answer is yes. If this sequence is possible, if the tallest child stands first, followed by the second tallest, and so on. So the answer is yes. This sequence is possible if the tallest child stands first, then the second tallest, then shortest, then fourth tallest, and at last the third tallest. So the arrangement would be tallest, second tallest, shortest, fourth tallest, and third tallest. Yes, this sequence is possible. Last question, seventh question is, how would you rearrange the 5 children so that the maximum number of children says 2? To maximize the number of children saying 2, we can arrange the children in a specific order. The arrangement would be tallest, next shortest, next tallest, next shortest, next tallest. So, if we arrange like this, then 2 children will say 2. We need to arrange the children so that as many children as possible have taller neighbors on both sides. So this is the maximum number of possibilities where the children say 2. I hope you understand how to solve these type of problems in numbers. If you have any doubts regarding this video, please ask me in the comment section. Thank you for watching. If you like this video, please don't forget to like, share and subscribe for more videos. See you in the next video.